Have you ever thought about making a cloud? Probably not, but through the power of chemistry, we can.
Hello, we are the Texas A&M University Kingsville American Chemical Society members.
And we're going to show you how to make your own personal cloud using a 70% solution of rubbing alcohol, a hand pump, and an empty 2-liter bottle to allow the alcohol to evaporate and form a vapor.
In nature, clouds form in the atmosphere when water molecules cool off and condense, meaning they turn from a gas to a liquid in the air. Through the power of chemistry, we can mimic actual clouds. Using the same concept that explains how clouds form in the sky, the alcohol evaporates to form a vapor. To encourage the alcohol to evaporate, we swirl it around the bottle. Remember to keep a firm grip on the bottle. Now, let's take a closer look. On the microscopic level, we can see how the molecules of the alcohol vaporize.
Now, how do we form the clouds? We know that clouds in nature condense, so how can we get the alcohol to condense? We need to utilize the ideal gas law. What you saw at the beginning of this video was actually the ideal gas law in action. The ideal gas law describes the macroscopic properties of ideal gases using the equation PV equals nRT.
In our case, we only need the simplified relationship, where P is for pressure caused by the gas bumping into the walls, V is the volume of the bottle, and T is the temperature of the gas inside the bottle. When the pressure increases, the molecules move around more, which increases the temperature. And it works the other way too. If the pressure suddenly drops, then so will the temperature. And thus, pressure and temperature are directly related.
By increasing the pressure within the bottle with a hand pump and then quickly releasing the pressure, we create a rapid decrease in pressure while maintaining a constant volume. This will cause the rapid drop in temperature we need for condensation. As predicted by the ideal gas law, the changes in pressure causes a drop in temperature. The alcohol, which is fairly volatile, then rapidly condenses to form a cloud of droplets.
Now let's put it all together. Swirling the rubbing alcohol around the bottle encourages the alcohol to evaporate, and the resulting vapor fills the bottle. Using the hand pump increases the pressure inside the bottle. When you remove the pump, or the rubber stopper as shown here, the pressure is rapidly reduced, while the volume remains constant. As predicted by the ideal gas law, the change in pressure causes a drop in temperature. The alcohol, which is fairly volatile, rapidly condenses to form a cloud of droplets. This is the same concept that the formation of actual clouds work on. Clouds form in the atmosphere when water molecules cool off and condense on dust particles in the air.
And there you have it, your own personal cloud. Today we learned about the ideal gas law and how the direct relationship between pressure and temperature is vital to understanding this experiment. You can also ask more questions about the limitations of this experiment, like how long does the cloud stick around for? And are you able to repeat the cloud formation? If so, how many times? Now that the experiment is completed, cleanup begins.
On behalf of our ACS student chapter and the chemistry department here at Texas A&M University Kingsville, thank you for watching.